Greetings, student. This is a recording of one of Garnett's online math lesson classes. You have been granted access to watch this video because you're a paying student and I have seen it fit to provide this recording to you. However, it is important that you know you're not allowed to share this video with persons outside the lessons. This policy is so that my services are kept only to my students. Thank you, and I do hope you enjoy and learn from this video.
Data frequency with group data is the same, but there's a caveat that we need to go through. So let's move on from that. This is using it to answer questions, but let's move on from that and actually go through constructing cumulative frequency tables for grouped data. Right. So right away, you know, this is a group frequency table because we have classes instead of the straightforward observations. Right. So we have our classes here and our frequency. This is a typical grouped data frequency table. We're going to convert this into a cumulative frequency table. Usually you need your frequency table to get your cumulative frequency table, right? Or I can give you the cumulative frequency table straight away and ask you to answer some questions on that, right? So it's the same thing. Now what you see here might look confusing, so the first step is our observation column for our cumulative frequency, right? And you know, it's always more than or less than. You can use less than as well. Now this column, you have your cumulative frequency column, but the observation column is a bit different than if we were just looking at on-group data. With on-group data, we just attach that less than or equal to sign to the observation. Now you don't do the same thing, so you don't expect to just put less than or equal to this, right? This is a group and it's not telling you anything. It's not very useful to do that, right? So what you do under the observation column for your cumulative frequency table is that you take the upper limit. This is what we call the upper limit for the group. So you can take the upper limit, right? So the upper limit, so you can put less than or equal to the upper limit for each of those classes or groups, right? So the first one, the upper limit for the first is 39, so less than or equal to 39. The upper limit for the second is less than or equal to 34, right? I'm going through and showing you guys how to construct these cumulative frequency tables from scratch, right? 49. This is 54. The upper limit is 54, so less than or equal to 54. Right. I go ahead. Now you may see it like this. So, right. So we can arrange our data set like this. The observation column, you can arrange it like this. There's another way to do it. You don't have to put it like this using the upper limit. You can actually use what is called the upper boundary. Right? You can also use what's called the upper boundary. So another way, you can have your observation column written like this, right? Using the upper limit, or you can use the upper boundary. Who here knows what the upper boundary is for a class interval? Anyone here know what the upper boundary is for a class interval? Limit plus 0.5, right? That's all the upper boundary is. This is the upper limit with plus 0.5. I told you guys what the upper limit is. The upper limit is basically the higher number in your class interval, right? The number on the right. If you notice, I was squaring off the number on the right and not the number of the left. This is what we call the lower limit. The upper limit is the higher number. The lower limit is the lower number. Sort of in the name, right? So lower and upper limits, and that's the name for these classes. There's some terminology for the class. So you have lower and upper limit, you have lower and upper boundary. Now the upper boundary is just the upper limit plus 0.5. 39.5, right? You notice I put less than and not less than or equal to. So if you're using the upper limit instead of the upper boundary instead of the upper limit of the class, then you need to just put less than, right? 4.5, you need to use less than. 49.5. So I'm just adding 5.5, sorry, to the upper boundary. This is what you can do. For your observation column, in your cumulative frequency table, you usually have the less than or equal sign. That's a given. But you put the less than or equal sign of your upper limit, or you put less than your upper boundary, right? And that's what we have here. Now, you will only use one of these. You're not going to use both. My suggestion is to use this one, right? Because you don't have to do any adding 0.5. If you're constructing your cumulative frequency table, if you're asked to construct your cumulative frequency table, my suggestion would just be to use the less than or equal to the upper limit, right? So just look at the upper limit and find that. So we know the observation for each one of our observation in the frequency table. Let's now calculate the cumulative frequency for each of those observations, right? Now it's already there. Nevertheless, it's the same as before. So let's take our time. So the first is always equal to the first. The first cumulative frequency is always equal to the first. It's sort of like saying there's nothing before, so 0 plus 12 is still 0, right? So the first cumulative frequency is just 12 for the first observation, right? So for the first row, it's just 12. For the second row, our second observation, less than or equal to 44, it's 12 plus 8. How do we know that? The first frequency is 12, coming down, it's, well, this is 12, right? 12 plus 8 will give us 20. So the second frequency is 20. We have to add the 20 to 10, that will give us 30. So the third one is for the third row or for the third observation or for less than or equal to 49, the cumulative frequency is 30. We go down to the second, the fourth class interval, and that's less than or equal to 54. We're adding 30 plus 37, 30 plus 7, 37. I'm jumping ahead, right? Right, so for the fifth one, this class interval 55 to 59, the cumulative frequency would be 37 plus 12, and that is 49. Because we're sort of adding up, because if we're adding up the frequencies as we go down, if we reach the last frequency, it's sort of like doing the same thing as adding the total frequency. So it's actually the same thing as adding the total frequency. So it's that's why the final cumulative frequency is equal to the total frequency. And I want you guys to look at these cumulative frequencies as just the total frequency at a specific point in your frequency table, right? So we're going down. We don't go up, we usually go down. We're going down, the total frequency here is 20. We're going down here, the total frequency here is 30, because 12 plus 8 plus 10 will give you 30. It's basically like that, right? As you go down, you're just totaling it till you reach the bottom. That's what your cumulative frequency is. It's the frequency accumulating as you go farther and farther into your data set. Now, in most cases, you won't even have to construct it because it will be constructed for you. But it's good to know how to construct it either way. Now, what do you use the cumulative frequency table for? Why am I going ahead and doing all of this? Why am I going ahead and adding the total here and getting this cumulative frequency, these numbers? How useful are these numbers going to be, right? And I will show you that in some examples, right? But what to expect is that these tables are used to answer questions like how many items, a value no more than or less than a given amount, right? If you want to know, use the examples because I really don't think I could explain it just like that, right? But we'll go through some examples. How many items are more than or less than a given amount, or less than or more than a given amount? But you don't necessarily, the thing about the cumulative frequency table is that you don't necessarily need the cumulative frequency table to answer these questions. because I don't want to tell you, okay, this is what the cumulative frequency table is used to answer, and this is the only thing you can use to answer these questions. Because you could reason it out just using your frequency table. And I went through that last class, right? We could have found those answers by just simply looking at the frequency table. We didn't have to go ahead and look at the cumulative frequency table, right? But sometimes we're not given both. Sometimes you only have your cumulative frequency table to look at. So you got to be able to interpret it either way, right? But I'm not going to try to tell you that that's the only way of answering those questions. All right, so the grouped frequency distribution of 120 candidates. 120 candidates already tells us that the total frequency will be 120. So a grouped frequency distribution. Now it says grouped as key as I'm trying to. It says group, which means we expect our observations to be expressed as class intervals or groups. Right? So we have our observation in groups, group data. We're dealing with a group data set. Right? Good. So keep that in mind. The grouped frequency distribution of marks of 120 candidates in an examination, call it C-second examination, is given, right? So we have our frequency table. So between 0 and 4, yeah. So now to read this off, right? The frequency is a group frequency distribution of marks, right? So this is the marks. Yeah, these are the marks. These are the number of students, right? The frequency is usually the number of persons in the class, the number of students, the persons that are participating in your data set, right? So get that, because I don't want you guys to be confusing the two, right? So the frequency in this case, the group frequency distribution of marks of 120 candidates. So the total frequency is 120 candidates. This column is referring to the number of candidates, right? Trying to show you guys how to interpret these tables. So this frequency is actually the number of candidates. I remember frequency is just a statistical term, right? We still got to be able to use the layman terms for these things, right? Number of candidates. And over here, if this is the frequency, if this is the number of candidates, what would be over here? What is this data, these class intervals representing? So if this is the number of candidates, then over here, of course, like Brianna mentioned, would be our marks. Right? So the two persons got between 0 and 4 marks. And I'm reading this off. I'm not going into the question as yet, if you notice. I'm showing you guys how to interpret these frequency tables. Right? So 2 persons, because remember, again, this number is referring to candidates, right? This column, we established that. And this is referring to marks. We established that. So between 0 and 4 marks, two candidates received between 0 and 4. Right away, they failed the exam. Between 5 and 9, 4 persons. Right? Between 20 and 24 marks, 24 students, 24 candidates, sorry, 25 and 29, 26 candidates, so on and so forth. That's how you would interpret it. So, right, I'm going to be doing that. I will take time to do that because I want you guys to be able to make that connection. These are not just values you're looking at, it's actual data, right? This is not the value and addition part of maths. Statistics is actually working with real life data, right? So let's actually move on to the question. Enough of that. The first question is asking to represent the data using a cumulative frequency table, right? We're going to represent this data set using cumulative frequency table. I want to do all the construction in front of your face and not just, I don't want the answers to just pop up. Let's take our time and construct, right? Good, so we have our frequency table. Let's construct the cumulative frequency table. So again, the first column is usually your observation column, and that is marks, or the intervals, the class intervals, right? And what goes in this column? What would be the first? Yeah, I already gave away it, so that's outside. But what will go here first? Anyone? Anyone? 4, not just 4. I'll go here first. I'm seeing 4.
Less than 4.5.
Less than 4.5. All right. Less than 4.5. Or what else we can put? Instead of less than 4.5, we can put. What else instead of less than 4.5 can we put? 4. You can't
Less
put
than or equal
4.
to 4?
Less than or equal to 4. Right? Don't put the numbers back.
That is what I meant, okay?
Well, you typed 4. I'm just saying 4. Good, right? So we do the same thing, right? So yeah, I want to use this 0.5 thing, but okay, that is fine. It's still correct. Just make sure not to put. Don't ever get mixed up and put less than or equal to 9.5, right? You have to use the upper limit if you want to use a less than or equal to. There's a reason for that. Sorry. So I got it. All right, we're finished with writing up the observation column. Let's do the cumulative frequency. What's going to be in our first? What's going to be our first cumulative frequency?
2, sir.
What was going to be the last one, the final one? We can jump straight to the final one.
120.
120, right? Because that's our total frequency. Good. So let's go ahead. We'll go here. What's the second? You guys do the addition. Come on.
7.
Right. All right. Close 6, right? 2 plus 4 is 6. All right. So this is 6. Open. Keep
There's
going.
my iron in class.
All right. Keep going. Keep going. 6 plus 8.
14.
14?
Keep going.
37.
37. Wait, 37. You got 14 plus 17 is 37. For some reason, I can't hang now.
31, sir.
31.
31. There's something wrong with my eyes.
Something else. You need to get your eyes checked. Let's keep going.
55.
81, sir.
55, 81. I believe the 81. Simple as this. Right. Now let's actually use it to answer questions. Matter of fact, we'll use both. Right. So it's the same thing. It's the same thing. Here I just you see here I just used the upper limit, right? The upper limit for each constant form. But you guys know we can use either the upper limit or the upper boundary. Good. So the second part, let's go back and then go forward. So we finished with the first question, which tells us to construct the table. And the second part says use the cumulative frequency table to estimate the number of students who receive a score more than 20 but less than 44 marks. I'm jumping ahead, right? And the proportion of students who received more than 39 marks, right? So let's so let me do it both ways. So I want to show you guys how to do it with just using a frequency table. You don't need a cumulative frequency table, as it says there in red. And I'm going to show you guys how to do it without. And it's not that difficult. So you might say this common sense, right? So the number of students who received more than 29, so they're receiving more than 29. More than 29 would be from 30, right? So they're receiving from 30 marks upwards, but less than or equal to 44. So from 30 to 44 marks, right? So the candidates that are receiving from 30 to 44 marks would be, right, between 30, the total marks from between 30 to 44 would be 15 plus 12 plus 9, right? You guys follow me? How did I get those numbers? Right here, right? Right here, 15 plus 12 plus 9. Because I'm looking at any number between 30 to 34 to 30, then 35 to 39, then 40 to 44. That is everything within this district or these classes, right? So 15 plus 12 plus 19 will give me, somebody got to do this. 15 plus 12 is 27. So 26. Okay, I'll say it's 26. So 26 candidates. Somebody double check.
Sure, I got 36. But you know, something wrong with me eye.
All right, yeah, it's 36. 36. Put students, it should be candidates, right? Good, so we got that. Next question says the proportion of students who receive more than 39, right? More than 39. So more, right? So more than 39 would be, anything more than 39 would be from 40 upwards, and we stopped at 49. So everything within this district, right? So 9 plus 3. And what do you understand? So 9 plus 3. 9 plus 3 is equal to 12. But will you understand when it says proportions? What do you understand by the word proportion? What does that mean? So another word in maths in particular would be fraction, right? So they're asking for the fraction of students, right? I mean, no fraction, a fraction or portion of students that got 39 marks, or more than 39 marks. So 12 students got 39 marks, 12 candidates. I keep saying students, but the students probably are, the candidates are probably students. Not necessarily though, right? But 12 of them got more than 39, right? But I want to know the fraction of students that got more than 39, not how much, but in terms of a proportion or in terms of a fraction. So what do we have to do? Put the 12 over the total, right? So whenever you're asked for the proportion or fraction, it's just amount. So this 12 gives us the amount, right? The number of students. This 12 gives us the amount. But we don't want to know the amount. We want to know the fraction. So to get a fraction, it's always amount over total. And it's the same as probability, right? Amount over total, it's probability. So this fraction will come back. I will bring this up back. Amount over total. The amount of something over the total of everything is the fraction. So, right, and we can do this in our heads. 12 into 12, 1, 12 into 120, 10. So 1/10. So the fraction of students who got, or the proportion of students who received more than 39 marks is 1/10 or 0.1. Is everyone following so far? 36 candidates for the first question and 1/10 for the second one. Good, so same questions. Use the cumulative frequency table to estimate the number of students who received more than 29 marks but less than or equal to 44 marks. And the proportion of students who received more than 29. All right, good. So right away, we want to know more than 29 marks. Now, you want to know more than 29? You look for 29 on your frequency table. Look for those numbers on your cumulative frequency table. Those numbers are going to be there on your cumulative frequency table. All these numbers, you notice 44, 39, they're all numbers on our cumulative frequency table, right? Well, you might have 0.5 if you chose to do the other one. right? But they're still accounted for, right? Still accounted for. So they're all numbers on your cumulative frequency table. So you're going to go straight to that cumulative frequency. So more than, who received more than 29, sorry. So go straight to 29. 29 is 801. The cumulative frequency of 29 is 801. So more than would be this way. Anytime you're referring to a frequency more than, you're going to go in this direction, which is down. Because if you notice, down is increasing, right? So 34, then 39, then 30, then 44, then 49. So anytime it's more than, you go down, right? You find your cumulative frequency. I want to know more than 29, not less than 29. So find 29 and go down, but less than 44. So you're not going to go straight down to the bottom, which is your total frequency. You're going to come down to 44. So you're going to come straight down to 44, and you subtract the cumulative frequency for 29. So subtract the cumulative frequency for 39. For 39 by cumulative frequency for 29. Because again, not 39, 44, yikes. That's not 39. This is between 44. Again, the number of students or candidates who received more than 29, you go straight to 29. More than means you're coming all the way down, but less than 44 means that you're looking between 29 and 44. So you go down and you stop at 44. In other words, go get your 29 cumulative frequency for 29 and get your cumulative frequency for 44. And if we subtract the two, we should get the same answers before, right? Which was
36.
36. And we get 36, right? X. And we get 36, right? Good. So we get back the same answer. Now, good. Now in the second question, it says more than. Both are asking for more than. If you notice, both questions are asking for more than, right? It says more than 29. In this case, it just asks so who received the portion of students who received more than 39 marks, right? We got to find the amount of students and then find the fraction. So if we're looking at more than 39, we come to 39. And as I said, more than is this direction, you go straight down. Because it didn't say more than, but less than some other value, you go straight down to the total cumulative frequency, right? You go straight down to the bottom. So we go straight down to our final observation, our final frequency, and that is the total frequency, which is 108. So, and the only reason why we go straight down to the bottom is because, again, they didn't say but less than 44 and anything like that. That's the only way you stop at that value. So again, 39, 108, we come straight down to the bottom frequency, the final cumulative frequency, which is 120. All because they said more than 39. But so what we have to do is the same thing like before. If we want the amount, we just get the cumulative frequency for the total cumulative frequency, or the final cumulative frequency, which is 49. The cumulative frequency of 49, subtract that by the cumulative frequency at our 39. Right? So we get 120 subtracted by the 108, which is 12. But I don't want to know the amount because this is amount. They won't want to know the amount, they want to know the fraction, the portion. Right? So 12 over the total, which we already know is going to be 120, and that is 110. You guys think you get it? You want me to do another example? I think you should do another example.
Yes, sir.
I should do another example. So that is how you use cumulative frequency to answer questions like these. It's mostly just finding the value on your cumulative frequency table, getting the cumulative frequency for the value. If it's more than, you go straight to the bottom to your total frequency, you subtract those two. If it's less than, usually you just take the value, and I'll show you guys that. Actually, let's work on an example and include that. All right, good. So final example for the night, and then we're going to close off. Looking at cumulative frequency table and interpreting, using it to answer some simple problems. So, as I said, this is a CISA question. A farmer kept record of his citrus over 8 weeks in the cumulative frequency table below, right? And the cumulative frequency here is the number of boxes. Yeah, right. So the cumulative frequency is the number of boxes, and your observation is the days, right? The days. Now, notice how frequency or cumulative frequency in this case does not refer to number of persons. So it's not always that frequency will be number of persons, right? In this case, it's the number of boxes because that's what he's counting, right? He's counting number of boxes of citrus, right? So use the cumulative frequency to determine the number of boxes collected in the first 21 days. Then we're going to use it to get the number of boxes collected between days 35 and 49. All of these questions can be answered just by looking at the cumulative frequency table. Now, I hoped if you had the chance, you looked at the questions, right? So let's tackle the first one, the number of boxes collected in the first 21 days. Anyone want to guess what the answer here is?
Sir, 48.
48, right? Because the less than or equal to 21 days, the cumulative frequency is 48, right? And that's what cumulative frequency does. It gives you these values if you're referring to frequency accumulated over time, over some particular period, or even over some particular period, right? So if it's the first 21 days, how much was collected over 21 days, you're talking about the cumulative frequency there, right? So right away, you just need to go to the cumulative, observation for 21 days, and that is 48. So the cumulative frequency is 48. Hence, the number of boxes of citrus collected in the first 28 days is just 48. Okay. Again, cumulative frequency. That's how cumulative frequency works. Right. So the answer to the first one is just 48. Well done. The next one says the number of boxes of citrus between days 35 and 49. As I said before, these numbers, most of these numbers are just going to be straight on your cumulative frequency table, and it's best just to go straight to them. So between 35 and 39, we go to the cumulative frequency for 35, and that is for days 35, right? These are all days, and that is 96, right? And 49 is 120, 130. So anybody want to guess what you have to do here? You got to subtract, right? It's sort of like saying more, let me put it like that. It's like saying between 35 and 49. We just need to go again. It's the same thing like what we were doing before. You're going from 35 days down and you're stopping at 45, at day 45. What is the accumulation between days 35 to 49? Is the difference between the two cumulative frequencies, right? So of course we don't want negative, so you have to subtract the large number by the small number. So 130 minus 96, and that'll leave us with
34.
34. I see some students are jumping ahead, but yes, that's what you do. So just look at the correlation. So you're reading off your cumulative frequencies from your table. Now Now the last two questions. Let's see if you guys are. Let's see. This one I believe it's simple. So the third question asks the total number of boxes the farmer collected over 8 weeks. Right. The total number of boxes the farmer collected over 8 weeks. What's the answer for this one? Anyone with a guess for the answer for number part 3? $140. All right, so you're saying 140. Why 140? Let me hear.
Sir, because it said over 8 weeks.
Said over 8 weeks, yes. So because it's over 8 weeks, you know it's 140. Okay, you are correct. It is 140, but your reasoning might be right, but it's how you explained it, right? All right, so it's 140 because the total frequency is of 140, right? The total number of boxes refers to the total frequency, and the total frequency over 8 weeks. If you notice, this is the record kept over 8 weeks. So the total frequency would be the last frequency in our table, right? Which is 140.
Yes, sir, that's what I meant.
All right, so yes, that is correct, 140. Again, just simply because I'm over 8 weeks. If you want to get technical, 8 weeks is actually 56 days, right? So if you don't know that, 7 days make a week, 7 times 8, right? 7 days make a week, 7 times 8 is 56. And what is the cumulative frequency at 56? 140. Right? You can do it that way, or you could have figured out that you're asking for over 8 weeks, and all we have is data for over 8 weeks. So the final cumulative frequency will be for over 8 weeks, which is 140. And either way, the reason is solid, and our answer is 140. Right? Everyone okay so far?
Yes, sir.
All right, so let's see if you guys can get the last one. The last one is the most trickiest one. It usually is, right? And last time I gave this, I don't think anyone got tricked, right? They didn't get the bonus. They didn't get the points from that question, right? But we're not in a competition. Let's try and deduce this. The number of boxes of citrus collected in the last 14 days. The last, emphasis on last, the last 14 days. What do I need to look at? What cumulative frequencies do I need to look at? Right, close, not, nope. All right, you're telling me 49 and 56, but no. Let me see if anybody can figure out why she's wrong. Why not 49 and 56? You're on the right track. You're looking at the last. You're on the right track. We're looking at the days, right? We can look at the cumulative frequencies for the days, but the days are wrong. Not 49 and 56. One of them is correct. The other one is wrong.
42 and 56 you gotta look at because it's 14 days. So then it'd be 140 minus 112.
That is correct. All right. It's the last 14 days, not the last 7 days. If you notice, it's the accumulation in which your observation is just every 7 days is an observation. So 7 days 7, and then days 14, and then days 21. It's all 7, 7, 7, 7. So if we look at 49 and 56, this is actually the last 7 days. Right? This is actually the last 7 days. So you need to go up to 42 because you're looking at the last 14 days. If you subtract 14 from 56 from 42, you get 14, hence last 14 days. Okay. And the reason why you're looking at these last values is because these are the last days, right? You're not going to look at 14 because 14 here is the first 14 days, right? This refers to the first 14 days. The last 14 days would be coming from the 56, right? The first 14 days would go from here to 21, right? Again, it's 14 and this 7 and this, you might get, don't look at the number, it's 14 days, all right? Actually, you do need to look at the number here, right? 14 days. But it's not the first 14 days, you're looking at the last 14 days, right? And that is between days 42 and 56. No, not yet. All right, so the last 14 days, we've established it's between days 42 and 56. Right, that's the last 14 days. Again, how they know that is because 56 minus 42 gives us the 14 days. Right, and that's the last 14 days of which they're referring to. Now, how many boxes did he collect in the last 14 days? Like I said before, usually just go to your cumulative frequency. This is 112, and your cumulative frequency for the last one, 56, is 140. Just need to subtract those two frequencies, and it will give us that. Right? So the cumulative frequency for our 56 subtracted by the cumulative frequency for our 42 give us for the last 14 days. 140 minus 112. What this answer be? So the total of boxes would be 28, right? Most cases, right? This is one of the extreme questions that you can be asked. Usually, typically, it's as simple as you're gonna ask you what's the total frequency, and we know it's always the final frequency in our frequency table. We know to calculate between two cumulative frequencies. We just need to get those frequency and subtract them by each other. That's how you get the betweens, right? And to get collected in the first, well, to get the less than those exact values, you just need to go straight to the cumulative frequency, right? The last one is the last question is a bit tricky and just required you to figure out that last 14 days is referring to between 42 and 56, right? Because those days between 42 and 56 refers to the last 14 days, right? It just requires some reason to figure that out, and then it's the simple calculation like we were doing before. Just subtract the cumulative frequency for the 42 and the 56, right? The difference.